This section is on the central limit theorem, and this describes the relationship between a population and a sampling distribution of sample means. So there are two cases. The first case says, if samples of size n, where n is greater than or equal to 30, are drawn from any population with a mean mu and a standard deviation sigma, then the sampling distribution of sample means approximates a normal distribution. As the sample size increases, the better the approximation. So any population where the sample sizes are greater than or equal to 30 has a corresponding sampling distribution that is normally distributed. The second case says if the population itself is normally distributed, then the sampling distribution of sample means is normally distributed for any sample size n. So if the original population is normally distributed, then the corresponding sampling distribution is normally distributed for any sample size n. In either case, the mean of the sample means mu x bar is equal to the population mean mu. The standard deviation of the sample means sigma x bar is equal to the population standard deviation sigma divided by the square root of the sample size n. And sigma x bar is also known as the standard error of the mean. A population distribution is shown. Samples of size 100 are drawn. Verify that the corresponding sampling distribution of sample means has the correct mu x bar and sigma x bar. So mu x bar is equal to mu, which we know is 16.5. And this matches what they got for the sampling distribution. So those match. Sigma x bar is equal to sigma over the square root of n. So sigma is equal to 11.9 and n is equal to 100. So 11.9 divided by the square root of 100 is equal to 1.19. And that does match what they got.